There is a question from Dmitry.
Я хотел бы спросить профессора, вот в том представлении основного объекта финслеровой геометрии, который фигурировал у него в докладе.
Professor, in the main presentation of the object that you mentioned in your report,
фигурирует финслеров метрический тензор, зависящий от точки и от направления касательного пространства.
A metric tensor which depended on a point
and the direction.
Направление.
Да. А знаком ли он и как относится, если знаком, с тем предложением, которое развивается у нас в России и в Румынии?
Do you know what the trend which are under development in both Russia and Romania, which
когда основным объектом оказывается обобщение скалярного произведения.
Generalization of the inner product as the object.
Yeah, no, actually, that is why once I saw this development, then I was
увидел, что это существует.
Ну, то есть он
хотел принять участие в этом.
Спасибо.
Какие модели предлагались для использования финслеровой геометрии для обобщения общей теории относительности?
Какие модели использовались?
Как предлагались?
Actually, I have not applied to this particular anywhere. I have not applied anywhere.
Я не очень хорошо этим занимаюсь.
I have studied the 4-dimensional special Finsley space.
But we are with
5-dimensional, 6-dimensional. Now I have to see which one can be best suited to your case.
Пятимерными, шестимерными я должен сейчас посмотреть, какое из этих пространств будет лучшим образом соответствовать вашему случаю.
But you don't work in Rander's phase.
You don't.
I know. I have got a lot of work.
It was suggested that to generalize general relativity. No?
Было предложено.
Actually, the main attention of my main attention to participate in the conference was just I wanted to know that how and where how to apply this Finsler in a better way to your 4-dimensional this theory of relativity.
Но как-то уже используется.
This is why I am interested to learn something from you people, then to see how to best to apply it. Because nowadays the situation in the mathematics has changed. Please just a minute. Actually, in 16th or 17th century, the situation was different. There, the physicists and chemists had got a problem. Then they took the approach to the mathematician. In 16th,
the opportunity to translate, go a little bit. Stop from time
to
time.
Actually, in the 16th and 17th century, the situation was reversed.
Ситуация была.
Once the physicists and chemists had a problem.
Такова, что когда physicists had когда физики и химики имели проблемы,
they have got a problem. They approached to the mathematician. This is my difficulty. How to remove it? How to get over it?
Это было их трудностью, каким образом решить их проблему.
Then the mathematician said that you come after a month or 2 months. For example,
математик говорил при этом, ну, приходи через пару месяцев.
For example, suppose a particular physicist has to add 2 forces.
Ну, например, какому-нибудь физику приходилось в пятимерном пространстве складывать 2 силы.
Then the mathematician suggests him that you
предлагал
find out the component along different direction,
найти компонент в другом
then the square and take the root. That will be the resultant. Body will move in that
либо возвести в
direction.
квадрат, либо получить корень.
But now the situation had changed. Mathematician has done a lot of work. And it is the physicist and chemist who has to see how to and where to apply it.
И мы должны посмотреть, каким образом это можно использовать.
Now I'm here just to know actually what you people are doing and how I can apply and where to apply this Finsbury space or the models which I have worked out where they are best suited. I have got one research article on a 4-dimensional space in terms of scale. 4-dimensional Finsbury space in terms of scale. I am very much interested in case you people the time permits for tomorrow.
Мне это очень
In terms of
понимает,
scale.
и если вас это интересует, я мог бы выступить завтра с сообщением на эту тему.
1 minute.
Yes.
Any more questions? Riemann and a little bit about parallelism.
Parallelism, yeah.
Okay, whether you want it or not, because you said parallelism was introduced by Chivita, indeed I would agree with you. I wonder how much of parallelism there is in the original paper. Why? Because if you are talking about the straight lines, then you are talking about lines of constant direction. So there is automatically implicit the concept of parallel transport within the lines of constant direction. See? So what I'm going to do when I go home, and I guess you are going to do similarly, is to go to the original paper of 1854 and see how much he exactly says. And the other thing,
I have gone through that paper which he delivered in 18th June 1854.
yes, we know
18th June 1854, and I have got at least 10 times to that paper.
All right. And the other thing is, you didn't mention, this is very interesting, that the Riemannian curvature was not introduced in a paper in geometry, but in a paper on heat transfer in response, several years later, in response to a competition by the French Academy of Sciences. Okay? And maybe I think that's very interesting, because it is, Riemannian geometry was born as a problem, I mean the Riemannian curvature as a problem of equivalence. You probably
Anyway, I'm not going to continue it in case. I'm not going to continue.
Time is over. Professor Wood, please, he's going to leave. He wants to address us.